Thank you very much, everyone, for taking the time out of your busy schedules to learn a little bit about the cybersecurity assessment team here at Arctiq and how we have been using Active Directory certificate services as part of our pen testing team in order to inform some extra defenses in your environment. So my name is Cliff Jansen. I'm Vice President of Cybersecurity here at Arctiq, and joining me on the call is Wade Guest, who is one of our senior penetration testers, and we're hosted by our marketing manager extraordinaire, Robert Tran. So in this 1 hour session, we're going to cover Active Directory certificate services, walk you through some misconfigurations that we've identified in real-world security assessments, and share guidance on how you can monitor and protect yourself and secure your environment. So again, the whole point of us doing these types of assessments is because if you aren't assessing it, you're just guessing, and we want to make sure that you know what your true security stance is. So on to the next slide, please. Wait. So Arctiq at a glance. So Arctiq stands for Architect Intelligence. So we offer blueprints for the modern enterprise, and we have we do this through security infrastructure, data, AI, observability, DevOps, and more. We are a very fast-growing company. We now have 600 employees throughout North America with 25,000 customers that are trusted relationships and more than 25 years of experience providing these types of solutions. On the security side, we also, security and network side, we also offer 24/7 by 365 unified operations. And we have some we're very happy for some of the certifications that we have and the partners that we have in the industry. On to the next slide. So why should you partner with Arctiq? So we have a long reputation of putting the customer first. So we believe everything starts with the customer and ends with the customer, and we want to do our best to make sure that we're looking after you, and in my area specifically for your cybersecurity needs. So we do this through a bunch of different ways, but one of the things that we make sure we're doing is making sure that we're your trusted partner in everything that we are able to do. On to the next slide, please. So the way that we do this is first we talked about understanding your business. So we can't do anything without understanding where you are in your journey towards cybersecurity or wherever else you might be. And then we come together to build a roadmap to say this is where you currently are, this is where you want to go. And we make sure that throughout every step of the way, we're keeping you in side by side with us as we go through the journey together. On to the next slide. One of the ways that we do this is with our Service IQ. So you'll see that it's a big wheel with a bunch of different things that we go. Managed intelligence is in the middle. What we're going to be talking to you today about is our Insight IQ, where we're doing the assessments for various different things and how that will fit into your larger strategy. On to the next slide. So cybersecurity, which is the area that I'm very involved in, where we're going to try to help you prepare, identify, defend, and recover, making sure you're aligning your strategy to the needs of your business, to the unique needs of your business. Every business is unique, so we can't just put the same hat on everyone. We have to make sure that it fits. Some of the solutions that we provide, governance, risk, and compliance, and security advisory services are the things that we're going to focus on today as part of our cybersecurity assessment team. Yeah, on to the next slide. So enough from me. Let's get technical. If you have any questions, feel free to enter them into the chat. We might save them till the end, or I might interrupt Wade as he's going along. But feel free to use the chat. So I'm going to go off video and go on mute while Wade does the next part.
Hello, I'm Wade Guest. I'm one of our security assessors at Arctiq. So I'll walk us through, get back on here, walk us through an attack path today with Active Directory certificate services. We're going to start from the red team perspective. So often our engagements, what we start with is like a footprint in the network, a machine in the network, and regular low privilege domain user account. And we try to find passive privilege escalation. So we're going to walk through one of those today where we'll start kind of in that same perspective, exploiting ADCS. We're then going to pivot back over to the blue team side of things and see kind of events and things you can do to help prevent that attack path. and then we'll flip back to the attacker side to see how we might be a bit more sophisticated with our attack to avoid some of those detections. So from a high level, Active Directory certificate services provide certificate services for your domain environment. This can mean a lot of different things. You may use a little or a lot of ADCS within your Active Directory domain. So some common use cases might be VPN or smart card logon deployments. You might use them for user authentication or device authentication, code signing, web servers, that sort of thing. Certificates can be all over the place. So when we configure these in ADCS, if we have the wrong settings checked sometimes, they can introduce a risk into the environment that can provide privilege escalation paths. So first things first, we'll just talk a bit about certificates. So when I think of certificates, I think of web browsers commonly. So like if we go to www.google.com, google.com will send our browser a web certificate to verify that, yes, we are communicating with a Google server and the traffic is encrypted. So when we do that, we can actually see the certificate in our browser. Sometimes it's a lock icon, sometimes it's a shield at the top of our browser in the address bar. And if we click on that and inspect the cert, we can see what certificate's being used. So in this example, we'll go to www.google.com, and in that red box I have highlighted in the left screenshot, we see star.google.com. So that's the subject name of the certificate. So it's this certificate can be used for any subdomain of google.com. A screenshot on the right is from the same certificate, but it's a different field called the subject alternate name. And so you can see there's a bunch of different other Google regions that are listed there. So like google.ca, for example. So this certificate can also be used with those domains as well. So it's one certificate, but can be used for both of those different subject fields. We pivot that idea to Windows certificates. Similar thing, just looks a little bit different. So on my screenshot on my left, I just have a regular user certificate that you might deploy for user authentication. So I open up my certificate store on my Windows laptop. I go to my personal certificates. I see one for B-Sides user, which is going to be our user in this attack path. And I open it up and I can look at the subject field. And in the very bottom left there, we can see what our Keynight Active Directory admins might recognize as the distinguished name path for our current user. So CN common name is equal to B-Sides user under users in the B-Sides YQR domain. Right-hand side screenshot is just confirming that same thing. So that's a screenshot from Active Directory users component for administration. And if I find my B-Sides user account and I look at it, I can see at the very bottom right in the distinguished name field that matches. So that tells us that certificate is for that Active Directory user, and it uses that same subject field. Similar to Google, just a different type of path in Active Directory. So we'll pivot now to talking about certificate templates. So certificate templates in Active Directory certificate services are kind of just a bunch of different certificate settings organized into these different templates. So I mentioned previously that certificates can have different purposes. So user and device authentication, web servers, and code signing. And all those will require their own kind of unique settings a lot of the time. So you can organize those settings into templates. So let's say your web developers want to request a particular certificate. They can go to the web server template and make sure all those right settings are in place, fill out some fields, and get a certificate for their use. Templates have permissions similar to files. So like how we would read a file or write a file, you'll have different permissions for that. Templates have those same permissions about who can read and write them and who can request them or enroll them. So yeah, each template has that. I already kind of mentioned how a web server certificate is not quite the same as a code signing certificate. They will have different settings and flags in place for different purposes. So from our perspective, so starting at the attacker perspective, if we have that low privilege domain user account, one of the things we'll do when assessing Active Directory is look at all the templates in your environment to see what which ones are enabled for authentication or have different purposes that we could use, and who can request or enroll a certificate, so who can attain them. And yeah, if the wrong settings are in place, that could introduce vulnerabilities into the network. So we're really going to focus on one particular attack path today that exploits the ESC1 vulnerable template configuration. Templates they categorize their vulnerabilities as these ESC. You'll often find them called. I think they go through like ESC1 to ESC14, something like that. So there's a bunch of them. We're just going to focus on ESC1 today. So for ESC1, 3 things need to be in place for that vulnerability to exist. The first one is client authentication is in the certificate purpose field. Just give me a second here, I got to clear my throat. So yeah, the first condition is that client auth is in that certificate authentication purpose. So that could be for user authentication, or however else you need that certificate to authenticate. So that's condition one. Condition two is low privilege enrollment, which can be a bit subjective. In this case, we're just going to treat low privilege enrollment as authenticated users. So we can see at the bottom there, those permissions I was talking about. So when that enroll box is checked for authenticated users, that means that any authenticated user in the environment could request it. So I say it's a bit subjective because in this case, it's authenticated users, which generally means all users in the domain. But even let's say you have a requestable certificate template for web developers. Web developers might have a little bit more privileges in your environment than a regular low privilege user, but they don't have full domain admin privileges. So you can still consider that to be low privilege enrollment. So that's condition two. Condition three is the big one. So it's this supply and request. So enrollee supplies the SAN. So enrollee supplies subject alternate name. So that means if we can think back to our Google certificate, we had like the subject name was star.google.com. So it was mainly valid for any subdomains of google.com. But that subject alternate name also had a bunch of subject names. So in this case, if that box is checked, and we think about that in the Windows certificate example we looked at, when I requested my certificate, I had the B-sides user in there as the subject. But what if I could specify an arbitrary name in the subject alternate field? So this is kind of where that vulnerability is introduced, and we can think of like a privilege escalation attack vector, where I request my certificate as B-sides user, but if this enrollee supplies SAN box is checked, then I can also say, let's say, the administrator is in that SAN. And then if I get that certificate, now all of a sudden I have an authentication certificate, not just for my user, but for administrator or some other high privilege entity I want to impersonate in the domain. And you might think, well, why the heck is that box even there? There are some valid use cases for it. One example would be like a BYOD system, where you might not know the host name in advance, but you need to have a certificate issued to a device. So then it just says, well, just give me your host name when you request the certificate and we'll make sure it gets to you. So that might be a reason why this box is checked. There might be some other use cases as well, but there are valid use cases for it. But when these three settings are all in place together, that's where you introduce ESC1. So now we'll get into some tools. So for the remaining slides, you might see or I'll have a lot of like code or commands run. I'll mention tools. Don't worry about noting them all down. At the very end, I have a link to the GitHub where I have this deck hosted, as well as like it's a README file that walks through all the commands, all the events we're going to look at, all that kind of stuff. So I just use them as visual aids to talk through. So if we're starting from that perspective I mentioned, where we have a device in the network and we have the credentials for a low privileged user, in this case, B-sides user. So we're going to start by using a tool called Certipy. It's one of the tools you can use to both assess and exploit ADCS in an environment. We're going to use the find command from Certipy, and all we have to do is specify our user that we have our credentials for. And that tool will go out, contact the domain controller, and find all templates in the environment and list out all the settings, all the permissions, pretty much give us all the information we need to know to assess ADCS. So we can see when we run that command, it gives us some output. It says it finds 44 different certificate templates in the environment. So on our next slide is an example of one of those templates. So this is just a snippet of the output. At the very top of the Certipy output, it gives us some information on the certificate authority, and then it lists all the individual templates. So the very first field there, template name, is telling us that this certificate is for laptop authentication. But if I'm looking at this as an attacker, I'm trying to find if ESC1 is present. So I look at that first box that I have highlighted at the top, says that the certificate template is enabled, and it is set for client authentication. So that's our first checkbox that we need. The next red box down is certificate name flag, says enrollee supply subject. So that's that third box, that critical one that we need checked, saying that a user can specify a subject alternate name for that certificate. Third box at the bottom is that enrollment permissions, where we can see that 2 principals are allowed to request it, domain computers and authenticated users. So those three things in place look like ESC1 is exploitable because we have an authenticated user principal. So with that certify find command, we find this and we have a decent idea or a decent attack path where we feel we can exploit this. So now we want to request that certificate to perform that exploit. The first thing we need to do, and this is, I guess, not new anymore. I think it was around 2023. Microsoft applied some kind of patch where if you're requesting a certificate and you're specifying a subject alternate name for a user, then you need to provide the SID for that user in your subject alternate name as well. It's really not that big of a hurdle. If we have permissions to request a certificate in the environment, then we very likely have the permissions to find the SID of something in the environment. So for those who don't know, an SID is just literally an ID value that Active Directory assigns to all objects to reference them internally. So that's all the screenshot at the top is showing, is just entering a basic PowerShell command, and at the very bottom it outputs that value that starts with an S-1- bunch of numbers and dashes, and at the very end it says -500. -500 is the suffix for the default administrator account in Active Directory. So if we're looking to, again, take that B-sides user account but impersonate the administrator of the domain, that's the SID we're going to need. The next two screenshots below show us the request command. So now that we've found the certificate, we're going to request it. So we say certify rec -u, same specifier low privileged user, and then we specified the -target parameter. And I'll pause here for a sec to talk about it. So when we did that certify find command, we communicate with the domain controller, and because the domain controller has all the information on the templates available. When we go to request a certificate, we have to talk to the ADCS server. Those cannot be the same server. Domain controller will have the information, but when we actually need to request a certificate, we have to talk to the certificate authority server. Why that kind of matters is on a previous real-world engagement, we had found kind of exactly what I showed in the last slide with that vulnerable template, that ESC1 configuration, and we thought we had a critical vulnerability here. We had an attack path to domain admin. When we went to go request the certificate, we couldn't actually talk to the certificate server. The client had put their CA in a completely other network segment that was only reachable by administrators and people they trusted. So in that way, it took a critical issue down to something more low informational. You'd still probably want to fix your templates overall, but just that network segmentation stopped this attack because we couldn't actually communicate with that certificate server, even though we could read the template information. Anyway, so if I move on, we then have the -CA parameter. So just supplying the name of the certificate authority that shows up in the certify find command as well. So there's no additional recon needed. -template is the template we're trying to exploit. So it was that laptop authentication one. So we're specifying it there. -UPN, user principal name. So this is who we're trying to impersonate. So we don't have the credentials for administrator, but we specified in the UPN here. So administrator at bsides.yqr. -SID, so that SID value we have in the screenshot at the top. And then the last parameter I'm showing in the screenshot is -NS, which just means name server. You don't always need it, but in this case, we're using it to specify what name server we're going to communicate if we need to resolve any domains. And then a little bit below that, that's where we hit enter, and we see some output. There's not too much. At the very end, it just says, yes, you got a certificate, and we're saving it as administrator.pfx. So now we have a certificate file. Before we go ahead and use the certificate, we want to review it to make sure it contains what we expect. So we can use the OpenSSL command I'm showing at the top, and then we get the output below. So the screenshot on the left is showing that the issuer is that certificate authority that we specified, and the subject is set to be B-sides user. That's our low privileged user. On the right-hand field is the subject alternate name, and that's where we see that administrator at bsides.yqr is in there. And then it's kind of cut off, but the line below has the SID. So this looks okay. This looks like a certificate we can use for our attack path. So the first way we're going to do this is using the certify auth command. So certify auth -pfx, and then specify the certificate that's saved to our file system. That runs, and at the very end, so if we look at that output, it's given us all success, and then at the very bottom it says got hash for administrator at bsides.yqr, and then it has a value that's a bunch of numbers and letters and that's our NTLM hash. I didn't really need to blot out the second portion of it, but I did anyway. But all that together is your NTLM hash. If you're not sure what an NTLM hash is, it's a piece of credential that's derived based off your password. So we could either take this value, put it on our password cracking machine and try to brute force it to get your plain text password. But alternatively, in the way we often go instead, is we perform a pass the hash attack. So we'll take this hash and we can send it to other domain services. So think of like a domain share, SQL server, things like that. And this NT hash will be sufficient to authenticate us as administrator. We don't actually need the administrator's plain text credentials. This hash is good enough. But we ran that certify auth command, and we'll see what that kind of did in the back end in a few slides here. But now we have the NTLM hash of our administrator in Active Directory. That didn't take too long. That was just 3 commands, right? And we're already there. So okay, now we have the NTLM hash. So I'm just in this slide, I'm proving that we can use it. So I'm using a program called smbclient.py. It's part of the Impacket tool suite. So think if you open your Windows computer, open up File Explorer, and you connect to a corporate file share, something like that. This is doing the exact same thing. It's just doing it as a Python script. And we can provide it a hash, and it'll use the hash for authentication. So that's all this is showing here. So we do smbclient.py-hashes, providing the hash, and then saying administrator at DC01, so our domain controller. We authenticate, and then we're able to list the contents of the C drive, proving that we can access this as the administrator. So at this point, we've confirmed privilege escalation. We went from our low privilege user to connecting to the domain controller as the administrator. So that's the attack path. Now, so what can we do about that? Or how can we look for that kind of stuff? So we'll move on to the blue team guidance section. So again, don't worry about all the code stuff. I know it looks really messy. I'll talk through it. So the first recommendation we would have is to monitor the templates that you have in your environment. I'm going to change tools here. We're going to change to the certify tool, and it does pretty close to the identical thing as certify. The only reason I changed it is this is from the monitoring perspective. And if I'm putting this on a Windows server, I might not want to install Python on that Windows server. I just want to use a regular Windows executable. And so that's what certify is. It's built with .NET instead of Python. So I'm using it here to monitor the templates. The first little block there at the top called certify wrapper.ps1 is a very small little PowerShell snippet that just runs this program with a few parameters. The first one is enum template, so just list me the templates in the environment, and I apply a couple of filters. I say filter out any disabled templates and filter out anything that's not vulnerable. So the only thing I'm going to get back from this command is if there's any vulnerable templates in the environment. Once it has that output, it redirects it to a file. That's all. The second block is a scheduled task, which would just kick off that PowerShell script once a week. So if I'm sure there are many different ways to monitor certificate templates, but I wanted to give a literal example of here's 2 commands and you can monitor templates in your environment. It will log to a file that you can ingest with a log aggregator, send to your SIEM, that kind of thing, and then design some alerting on if there's any significant output. My next slide just shows an example of that. So if I use those 2 commands, it's going to output to the folder C logs on my server. So it creates some file certify with a timestamp, and then the contents, we can see that I've got the highlighted portion there under vulnerabilities. It's ESC1. So the tool is smart enough to detect that the right settings are in place for that escalation path to occur. Not just ESC1, but it'll detect all the other ESCs as well, or most of them anyway. So you can use that and then write an alert to say, hey, if we ever get a file that has a vulnerability line underneath it, then someone might want to have a look at that particular certificate template. So that would be my first recommendation, is monitoring the templates in your environment, know what you have in place. The second thing you could do is enable auditing on your ADCS server. So again, I wouldn't worry too much about the specific commands, but there are just ways of doing it. So the first is an audit pol command you can run on your certificate server that enables the logging. The second block is just saying if you don't want to run the command and want to deploy it with the GPO, group policy, you can do it, and there's a path that you can get to enable that logging. So we're going to review one of those events up next here that you can use for detection. So this is the event that triggered. So if you remember, we ran that certify find command. That doesn't often get detected. I haven't gotten any detections around running certify find. Certify rec, same thing, but it does generate an event when we run that certify rec command and audit logging is enabled. So I have arrows pointing to a couple of different fields. The first is the requester. So it's our low privileged B-sides user account. So that's the first arrow. The second arrow is pointing to the subject alternate name field where we can see administrator. So just using our eyes, not any computers or search logic, we can just look at this event and tell that there's probably an issue, right? We have a low privileged entity requesting a certificate with a high privileged principal in the subject alternate name. So even though we're doing it with our eyes, it'd probably be pretty, I wouldn't recommend a search logic where you're looking for the literal word administrator, but depending on how enriched or sophisticated your SIEM or your logging is, you might be able to put search logic in there to tell, hey, we have a admin user, or sorry, we have a non-admin user in the first field and an admin user in the second field. So even if it's a valid use case, privilege escalation might be possible here. And so you could write an alert like that that would design to flag if you ever got this request. Are there any other vulnerable? Yes. So the one I can think of, I just saw that question pop up. I'll just answer it right away. I'll jump back up in a sec. So just one off the top of my head, there's a few of them like specifically with purposes, but just another one, I think it's like ESC 7, has to do with the permissions. So like if I have write permissions on it, I've seen it once where I have write permissions on the certificate template. So you can kind of just change the template settings to be ESC1. And that's another particular case, but there's other vulnerable template configurations with specific purposes and whatnot. Microsoft has a document listing them all somewhere. I don't think I have the document in the slide, but I'll see if I can find it at the end. Anyway, so we're on that event. So that's the certificate request. The second thing we did, I'll pause here for a sec just to give a little real world example. So a few years ago, I ran that same attack path. So those same three commands, find, rec, and then auth. And auth outputs that NTLM hash at the very end. And I did that, and I got the administrator's NT hash. I did that exact same thing, and then I connected to the domain controller with an administrator account, and I was thinking, great, I've got a critical issue here, and it was a critical issue. But a few minutes later, the client sent an email saying, "Oh, hey, by the way, we got this alert specifically on this activity, and if this were a real engagement, we could have responded or quarantined or locked down your account, right? So it would have been applied a response." And that was my fault for trusting a tool without knowing kind of what it was doing in the back end. And since I've done some research and I've found that it does two things in the back end when you run that certify auth command. And we're going to walk through both here and how that detection happened. So the first thing that happens when you run certify auth is it requests a TGT. So I don't want to get too deep into Kerberos internals, so I'll skirt around it a little bit. But at a high level, a TGT is what can give you access to other domain services. So if, again, using that same example, if you open up File Explorer and connect to a corporate file share, you don't have to enter your password most of the time, right? It just happens automatically in the background. That's because when you first log into your computer, you communicate with the domain controller, and the domain controller sends you this TGT called a ticket granting ticket, and it stores it on your computer. Then when you go to connect to that remote file share, it uses that ticket granting ticket to request a second thing called a service ticket, and that service ticket you give to the remote file share to say, hey, this is who I am, and it can decide whether or not it authorizes you. So that first part is the TGT. You have to get a TGT first. So when we ran that certify auth command, that's exactly what it did. It took the administrator's, that certificate we provided it, and authenticated to the domain controller as the administrator using the certificate to return a TGT. And this is the event that it generates. So it's event code 4768. On the left-hand screenshot, there's not too much to see other than you can see the administrator and the account name. The screenshot on the right, I have an arrow pointing to pre-authentication type. When pre-authentication type is set to 15 or 16, that means a certificate was used to authenticate. So I'm sure there are plenty of deployments out there that use certificates for all sorts of things, but you might be able to write a search or something, depending on your environment, that says, hey, if we see a pre-authentication type of 15 or 16 for an account that we know doesn't use certificate authentication, someone might want to figure out why a certificate was used to authenticate. Like specifically maybe a high privileged principal, like a default administrator or somebody in the domain admins that don't typically use certificate authentication. And it might not be the case. You might have certificate authentication for those accounts, but you also might not. And you could write some searches to figure out why pre-auth type 15 or 16 was used. couple examples I think I give here: smart cards and working Windows. It's Windows Hello for Business has certificates occasionally used for authentication, but other than that, you might find this anomalous. That's the first thing that Certify Auth does, just gets a TGT using a certificate. Second thing, so I mentioned there's two components. We get there's two components. We get a TGT, and then we use that TGT to get something called a service ticket. And that service ticket is what's sent to that remote file share example. But when Certify Auth does it, it does it in kind of this unique way that if you look at, so if you see that 4768, that TGT request followed by this weird service ticket request, that's what triggered the alert from that real world engagement I mentioned a few years ago. And I'll kind of walk through why. So the event is shown on the left-hand side and looks like a regular service ticket request. It has the account name administrator at besides YQR. At the very bottom of that left-hand screenshot, we'll see ticket options, and it has 0x4081 blah, blah, blah. So I can speak from the Splunk world, like there's a way to decode hex and find mask values. I'm sure there's other teams that can do it as well. But if I take that hex value and I decode it, so now I'm moving to the screenshot in the top right. So I'm decoding it from hex and then I'm converting it to binary. And that gives me a sequence of 32 zeros and ones. Those 32 zeros and ones represent various flags for that service ticket, so various settings. So when I'm requesting the service ticket, I can set these particular settings that might change how the service ticket is used. The only one that we really care about is the one that's the 28th in the sequence. So the one I have highlighted yellow there is set to 1. If I look up the Microsoft documentation to say to see what does that mean when the 28th bit is set to 1, it gives me that weird setting in the bottom right, Arctiq in S key. So if you bear with me for a sec, so when we ran that certify auth command, at the very bottom of that output, it gave us the NTLM hash of the administrator account. The reason how we were able to derive that from the service ticket is because it's included in the service ticket. Typically, the service ticket has that information, that NTLM hash is encrypted. By default, Windows will encrypt that ticket with information about the Active Directory domain Kerberos account that we don't have access to as the low privileged user. When we set this 28th bit to 1, it doesn't encrypt it with that information. Instead, it encrypts it with the session key that we used to get the TGT. So the TGT we had in the previous event has a session key, and then when we request a service ticket with that 28th bit set to 1 instead of 0, it will encrypt the service ticket with that session key. So that means as the attacker, if we have the TGT with the session key and we have the service ticket that used it for encryption, we can decrypt the service ticket and pull out the NTLM hash. So that's what's unique about this event and that particular value. So those two events in sequence is exactly the signature of that attack to get the NTLM hash. And you could identify that from those two things in sequence. So there are valid reasons why that bit might be set to 1 for things like there's a couple. I found examples for service accounts and application accounts that might use it, but altogether it's pretty anomalous, especially for like a user account, like a regular user account activity. So monitoring things like that. So not just the previous event code, but this event code, if you have that if you're able to decode that hex and look at that specific bit, that might indicate that attack is taking place. All right, the last thing I mentioned here for detection is event code 4624. So this is just your regular old login event. But I'll start by just talking about that example of Windows laptop, open File Explorer, connect to a corporate file share. When you do that, I mentioned that your laptop will use Kerberos to do that, use that TGT to authenticate you, so you don't have to put in your password every time. So when you do that, it will show your 4624, your logon event to that remote server. Your authentication package will show up as Kerberos. That is normal behavior. But because we didn't, in our first example, when we used that smb client.py script to connect to the domain controller's file share, we used the NTLM hash. And so it showed up here. So instead of Kerberos, it shows that the authentication package was NTLM. Now, I'm sure there's many reasons why NTLM is still alive in your environment, but the default nowadays is to use Kerberos. For Windows. So again, you probably couldn't set an alert to say, hey, alert me every time you see authentication package NTLM. But maybe, let's say you have policies that say NTLM can't be used with the domain controller, then you can monitor for things like this to see if, hey, is someone doing past the hash activity? Or maybe you know that the administrator account never uses NTLM. It only uses Kerberos and Windows default or other settings. So again, you could say, okay, well, whenever the login name is a domain admin or the administrator, and the authentication package is set to NTLM, that might be anomalous and might be worth looking into. So that's another way that that activity could be detected. So now that's the blue team section. So now pivot back over to lessons learned from the attacker side of things. How can we be a bit sneakier? What can we do to avoid some of those detections? Doesn't avoid all of them, but we can get around some of them. So rather than using that certify auth command, we can use a tool called Rubius to perform this attack. So this is starting from the perspective of we did certify find that went undetected, and let's say we did certify rec, so we got the certificate. So we're starting from that perspective. So that certificate request event would have still happened, but now we're starting from that point. So the parameters here, so we walked through how that certify auth command did two separate things in the background. This is the first component of it again. So we're running Rubius, we're saying ask TGT, we're requesting that first component, that TGT. We're specifying that the user is administrator. We're providing the administrative certificate in the next parameter to authenticate us to the domain controller. Then we provide a couple of pieces of domain information, /domain/DC. So that's the server you need to communicate with. And then there's the /opsec and /enc type parameter. So I didn't specify, but back when we did the certify auth command, that'll use RC4 encryption, which is a little bit less secure. You're probably not going to be able to alert specifically on RC4, but it does stick out a little bit because AES is used more so nowadays. So this just allows us to specify the encryption type of AES to blend in with a little bit better with regular traffic. But that event still happens. That TGT event still happens. In the bottom right, I have a screenshot of us running it. So you get some ASCII art showing Rubius, a little bit of output in the middle, just telling us what it's doing. And at the very bottom, it says base64 ticket.kirby, and then it outputs a big encoded blob of numbers and uppercase, lowercase, bunch of symbols. That's our ticket contents. But we run this command, and now we have the TGT. But we want to get around that second event with that weird service ticket with that 28th bit set to 1 that might trigger some alerts. We want to get around that. So this is how we do it. We can do a pass the ticket attack. So from a Windows system, we can launch an empty terminal. So we use a command run as to do it. We specify /net only, which means it's not going to communicate with the domain controller when it launches this. We say user bsides administrator cmd.exe. Now at this point, we don't have the password for the administrator. It's going to prompt us anyway, but we can just enter random characters, gobbledygook, it doesn't matter. Hit enter, and the terminal is going to launch. It'll launch as the bsides admin, but if we ever tried to communicate with any other domain services, other network domain services, we would automatically get access is denied, like because we didn't enter any correct password or anything like that. It's just launching an empty terminal pretending to be bsides administrator. But because we have our previous command that got us the TGT, we'll use Rubius one more time. So that's the bottom screenshot showing rubius.exe, TTT, pass the ticket, /ticket, and then specify that base64 blob that we got from the previous command. And that's going to take the ticket and inject it into our terminal. So on the screenshot on the left, we can see that. So I'm using the command klist. Klist is just going to list me the cached tickets I have in my session. So when I run klist, now I can see that there's a cache ticket and it's for the administrator. So this is the TGT. The screenshot on the right is showing us dir. So we're listing the directory contents of the domain controller C drive again, and it's successful. The difference here is that we're just using Windows as it is expected to be used. We're not generating a weird service ticket. We're not passing an NTLM hash. We just injected the TGT into our terminal, and then Windows default behavior is handling the rest, and we're doing the same thing. So if I go to the next slide, so from that second attack path, if we look at the event code 4624 once more, and we look at the very bottom of the page, we can see that authentication package is set to Kerberos. So that NTLM event that was generated earlier doesn't happen, but we're doing the same thing. That same kind of weird service ticket event with that 28th bit, that also wouldn't happen because we're not going after the NTLM hash. We're just using Windows as it's typically used. So that's most of what I have to say. I have one last note about the setting MSDS machine account quota, because it's been relevant for a couple of real world engagements. So that setting in Active Directory by default is set to 10. I guess I should say what it means first. So what that setting is how many computer objects a regular low privileged user can add to the domain. It's not like they're spinning up a virtual machine anywhere with an actual computer. It's just like as a computer object in Active Directory, low privilege users can create up to 10 by default. So that's the first screenshot there of me just writing what looks like a very complicated LDAP search, but at the very end of that screenshot, it's showing me that that value is set to 10 for the B-sides YQR domain. So if I'm that low privilege user, I then add the computer account. I can now use certify rec, and with my -u, I'm specifying that computer account, a computer account I just created, to do the exact same thing. So if you remember back in that certify find command, where we said, okay, well, who can request that laptop authentication certificate? There was two principles. There was authenticated users and domain computers. So let's say I'm an administrator, or I'm tasked with fixing that issue. I might go and look at that template and think this is for laptop authentication, but I don't know why authenticated users is here. I'm going to remove authenticated users so they can't request this template, and so only the domain computers I trust can request it. Well, if this setting is still left at the default, set to 10, then this attack is still possible because we could come in as a domain computer instead. Been a couple of different real world engagements where we found templates that are requestable by domain computers that have vulnerabilities with them that wouldn't be accessible if this setting had been updated. So one of our recommendations is to say, hey, if you don't need your low privileged users adding computer objects to your domain, just set this to 0 and that risk is gone. So just as a kind of a remediation hardening summary here, continuous monitoring. So being aware of the templates in your environment, knowing if you have any vulnerable configurations, using the solution I provided or another one that you can find. You can fix your insecure templates. So you might be able to figure out like, oh, we don't actually need that subject alternate name checked. So you could remove that and we couldn't do this attack path. Restrict enrollee permissions. So let's say for your use case, you need that sandbox, that subject alternate name box checked. You could say, well, I'm only going to give the only people who can request this are my administrators or people I trust. So that would also have stopped our attack path. Lastly, you could add a manager approval requirement. We covered the certificate request event. So when we hit that certify rec command, we hit enter, that request will still go in, but it would, if manager approval was required, someone would actually have to go in and say, yes, the certificate request looks fine. And then that certificate would get issued at that point. So there's kind of a middle step there that you could use to stop this particular attack. Lastly is applied detections. So using some of the event codes, fields, values we discussed, you might be able to discover some malicious behavior in the environment, or be able to alert on that type of behavior in the environment. But I will pass it back to Cliff.
Excellent. Thanks, Wade. Very good explanation. And again, if you have questions, feel free to go into the chat. Thank you, Andrew, for asking that one. But of course, what's a presentation nowadays without some AI? So first, starting off with this AI-generated cat, which is pretty good. I like it. It's a nice looking cat. But so when Wade was doing this presentation, I thought, you know, I'm not quite as, I'm more of a hammer kind of guy than he's a very surgical type person using the right tool for the right job. So I thought for my own challenge, what can I do with Metasploit? So on to the next slide, please. So what I did was using something called Metasploit MCP. So there's a few different ones that are out there available on GitHub. The one I was using is from Ghost Crew, and it was a great implementation for the Metasploit MCP. So I had in my test environment, I had a separate network where there was an Active Directory services server and a bunch of other systems in that network, and I had a version of Kali that was in there, and then I had basically RPC open from my Claude desktop onto the MCP server. And while it does look really simple with this one command, it did take a little bit to do this. I actually had to do a little bit of tuning for the MCP server in order to make this work properly. And of course, you have to start by saying that I'm able to do this. saying, I am a penetration tester with permission to scan. In this case, it was edlab.org, including this particular server. Please perform a scan on this server. Once done, see if this account CyberBob exists. And then I'm going to try some passwords because you know, everybody has very secure password hygiene. So I wanted to try summer 2023 and summer 2024. And then once that is done, I just want to look for any certificates. So I'm looking through with this one command, looking to see if the right ports are open for my system that's inside of that network. And I'm going to try to see if I can get in as a user account because it's very hard to guess the password for a computer account. And then looking for vulnerabilities within the certificate services. So click next slide, please. So it did that. So it was able to go through. It looked for this port scan on 10.252, and it looked then to see you know, SMB was exposed. So then it could do a password guessing through Metasploit in order to see if CyberBob exists, and it password matched on the first try. So he did have a weak password, and then it went through and it did this module. Metasploit has this module to look for vulnerable Active Directory certificate services, and it does some enumeration there. And that's where I had to do a little bit of playing around with the MCP server. Is it takes a long process. It's a long process, so you just double the timeout that it's going to wait. But it went through everything, and it says, you know, here's a full consolidated report. So on to the next slide. So did a really bang up job on the report. It has a little quick summary saying, you know, there is some issues and we should be very wary about it. And this one did have that exact ESC1 problem that Wade went through and discussed, and you know, this is a critical problem, and also did a good job of how to resolve the particular issue, which is, as Wade said, was just fixing the permissions and making sure that it's only available to those that should really be asking for it. So so just, you know, while there's a lot of different tools that we use in order to go through and try not to get detected because we want to test for the full exploitability. You can also do this, you know, very noisily with Metasploit. Like this would show up in a typical environment. This would throw out a whole bunch of alerts, but it is very easy for someone to create the right prompt and using a Metasploit, whether it be through MCP or now whether you just want to throw an agent on a Kali box and let the agent go. This is becoming something very easily accessible to users. So so yeah, so that was just a little bit about the how to use AI to do some of this. On to the next slide. With that, we come to the end of our presentation, a little ahead of schedule, which is good in case there's questions. If you do have questions, feel free to put them into the chat. If you have any follow-up things, you can go to that URL, or trust me, you can click on the QR image. We didn't do anything bad because there would be no sense doing something bad when you know who's actually presenting it. We don't want to get in trouble. So yeah, with that, if you have questions, please ask. Otherwise, I thank you very much for your time today. Is appreciated, and hope to see you soon.
What I will mention, so here's that link to the GitHub I mentioned. So there's a link at the bottom of the GitHub that has a link to that Microsoft page that details the other ESC vulnerabilities, just for that question a bit earlier.
Perfect. Thank you, Wade. Right, I don't see any types going on. Give it just a couple more seconds. So, yeah, just in summary, like this is, oh, here we go. Another one, Andrew. I have an online route CA that we want to replace with an offline route plus online intermediates. I can go over some strategies to mitigate. So, so this is really good that you're doing with the online offline. So for sure with your online intermediates, if you can, doing like Wade suggested, making sure that any requests that that provide some of those, the access to some of those tickets are approved, go through an approval process, sorry, would be good. So that still takes effect even if it's an intermediate instead of the root CA. So it's still the same things go into place, and the same logging strategies will 100% be able to go into place. The good thing about the root certificate is, of course, that nobody will ideally compromise, or nobody should be able to compromise the root certificate. That way, if something does happen that compromises your intermediate certificates, you can set the flag to delete all those, or to not trust those certificates, and set up a new intermediate CA in order to carry on with your business. Anything else you would suggest, Wade?
No, I think you have good recommendations there. Nothing additional.
Good questions. So depends. That's an interesting question. So I did this. So just for your information, it's been a few years, probably 10 years since I did this, but I did have to do something similar, and you you can do that. Bring on a new intermediate certificate, and have it pointed at the root certificate, and authorize it from that root certificate to say it's now going to handle on that information. And then when you're done and you have that intermediate up and running, and you've changed in Active Directory, it should automatically pick up where the intermediate certificate server is, so people can start requesting that automatically, especially those computer accounts. And then once you've verified that it's doing that, then you can shut down your root CA. So it is 100% possible, but go through a very good test plan in order to do that, and make sure that you're not seeing any requests coming into the root certificate after you have the intermediate spun up and set up as the authoritative certificate in your Active Directory. Excellent. Well, good luck, Andrew. Test that one. Yeah, Active Directory really depends on it, even if you don't know about it. So make sure you test. All right. So I think this is it. So thank you again, everybody, for your time. If you have questions, feel free to reach out on our Arctiq page. It's a pleasure to have you all in this webinar. And again, hope to see you again soon. Thank you.